Hello everybody, my name is Celeste Phillips. I'm taking Chemistry 1312 at EPCC. We're going to go over some extra credit answers and hopefully I can go ahead and teach you something. The phase diagram of a substance is given above. The substance is a blank at -10 degrees Celsius and 1 atmospheric pressure. So overall we're trying to see what phase it is. Right here in this W region, it is a solid. You're going to use this phase diagram. And then in this X region, it is a liquid. And in this Y region, it is a gas. So since they told us that the temperature is -10 degrees Celsius and 1 atmospheric pressure, we're going to go ahead and just look at the graph and line it up. You'll see that right now we're obviously in the solid region. So thus it's a solid. Alright, next question. So we're going to be calculating molality. We're going to calculate the molality of 32% by mass aqueous solution of phosphoric acid. So molality is moles of solute over kilograms of solvent. With the 32%, this implies that with 32 grams of phosphoric acid in 100 grams of the total solution. First, we have to calculate the moles of solute, and we can calculate this by finding the molar mass first of phosphoric acid. There's 3 hydrogens, 1 phosphorus, and 4 oxygens. So you're just going to go ahead and add up all of the molar masses. So you're going to look at your periodic table. So for hydrogen, it's 1.1. There's 3 of them. For phosphorus, the total is 30.97, and there's only 1. And for oxygen, there's 4 of those, and the molar mass is 16. So we're going to go ahead and add everything up. You're going to realize you have a total of 98 grams per mole. So we're going to go back, and we know overall of this solute, we have 32 grams. We're going to divide it by 98 grams per mole to find how much moles of solute we have. We cancel everything out, and we're going to end up with 0.3265 moles. Next, what we need to calculate is the kilograms of solvent. So we know already that we have 32 grams. So and we have overall solution of 100 grams. So 100 minus 32 is 68 grams, but we need kilograms. So 68 grams, we're going to convert it to kilograms, and you'll realize that we have 0.068 kilograms. So now we have the 2 values that we need to calculate molality. So we're just going to plug everything in. Molality equals 0.3265 moles divided by 0.068 kilograms to give us a total of 4.80 moles per kilogram. And that's our answer. A 1.35 molality aqueous solution of compound X has a boiling point of 101.4 Celsius. Which of the following could be compound X? The boiling point elevation constant for water is 0.52 Celsius per molality. So we're going to use the boiling point elevation formula. So it's delta T equals the boiling point elevation constant, which is K, times molality times the Van 't Hoff factor. So first, we're going to go ahead and see what our delta T is, which is the change in boiling point. We were given 101.4 Celsius, and since it's an aqueous solution, the boiling point would usually be 100 Celsius. So we subtract those from each other from final and initial, and we get 1.4 Celsius. Next, we were already given the boiling point elevation constant, and that's 0.52 Celsius per molality. And then finally, we're already given molality at 1.35. So right now, we don't have the Van 't Hoff factor. We need to figure that out. So first we'll go ahead and change the formula to see what the Van 't Hoff factor is. So we'll divide the boiling point elevation and molality on both sides to get I alone. And then we're gonna have Van 't Hoff factor equals the delta T over K and M. Okay, so we're gonna plug everything in that you already know. 1.4 Celsius divided by 0.52 Celsius per molality times the molality of 1.35. Want to calculate that, you can cancel everything out and you'll realize that it is 2. Because of the Van 't Hoff factor, how it dissociates, we know it's going to have to dissociate into 2 ions. So we'll go back to our options, and it has to be an option that dissociates into 2 ions. The first option is potassium chloride, and we know that that dissociates into 2 ions. So that's actually our answer. Answer is A.